Let's talk about something that you use literally every single second you're online, but you've probably never even thought about. It's called BGP, and it's basically the internet's hidden GPS. It's the unsung hero that's making sure everything you do online gets to where it's supposed to go. So, how does it all work? I mean, have you ever really stopped to think about it? You type in a website, hit enter, and boom, in less than a blink of an eye, the right page pops up. How in the world does your request navigate the insane, chaotic web of servers all across the planet to find the one it's looking for? Well, the answer is a surprisingly powerful protocol. And that protocol is the Border Gateway Protocol, or BGP for short. It's the internet's master traffic controller. The best way to think about it is like a global postal service. Every piece of data, every email, every video, every click is like a little package. BGP's job is to look at the address and figure out the absolute best way to get it there. Now, to really get this, you have to understand a key fact. The internet isn't just one giant single network. Not at all. It's actually a massive collection of thousands of independent networks, all connected to each other. These are called autonomous systems, and BGP is the glue that holds them all together. So what exactly is an autonomous system, or AS? Well, it's just the official name for a big network that's run by one organization. Think about your internet service provider, like Comcast or Verizon. That's an AS. A huge tech company like Google. That's an AS. A big university. Also an AS. This is what makes the internet so resilient. No one company owns it. And here's the crucial part. BGP doesn't care about what happens inside these networks. Its whole job, its only job, is to figure out the best paths between them. Okay, so if there are thousands of these autonomous systems all over the world, how does BGP actually pick the best route for your data to travel? This is where it gets really, really interesting, because BGP doesn't think like your car's GPS at all. This slide really nails the difference. See, most routing protocols are all about finding the shortest, fastest path from point A to point B, kind of like a GPS. But BGP is what's called a path vector protocol. And for BGP, the number one priority isn't speed or distance, it's policy. And that's absolutely critical because these networks are often run by competing companies that have different business deals, costs, and agreements with each other. And honestly, this is the perfect way to think about it. An airline might have a policy to never fly over a certain country, maybe for political reasons or security concerns. Even if that means the flight takes longer and burns more fuel, the policy comes first. BGP does the exact same thing for data. A network operator can set a rule that says, hey, don't send my traffic through this competitor's network because it costs too much. And BGP will honor that rule every single time. So how does it actually make the call? Well, it has a very specific checklist, a kind of tie-breaking logic. Number one, always, is follow the local policy. The rules come first. If there aren't any specific rules, then it looks for the path that goes through the fewest number of autonomous systems. After that, it might look at cost. And if everything is still a tie, it just sticks with the route it's known about the longest, the old, reliable one. This system works incredibly well, but it has one massive, glaring flaw. A flaw that comes from the fact that the internet was designed in a much simpler, more innocent time. The flaw is that the whole system is built on trust. And what happens when someone decides to break that trust? And there it is. For decades, BGP has operated on what's essentially an honor system. When one autonomous system stands up and announces to the world, hey everyone, I own this chunk of IP addresses. If you want to reach them, send your traffic to me, every other network just takes their word for it. There was no built-in way to prove they weren't lying. So you can probably guess what happens next, right? What if a network decides to lie? What if it claims to own a bunch of addresses that actually belong to someone else? Well, in 2008, the entire world found out in a pretty dramatic way. Back in February 2008, Pakistan Telecom decided it wanted to block YouTube for its own customers in Pakistan. But someone made a huge mistake. Instead of just blocking it internally, they accidentally announced to the entire internet that they were now the best destination for all of YouTube's IP addresses. And because BGP is built on trust, networks all over the globe believed it. They immediately started redirecting all of their YouTube traffic to Pakistan Telecom. The result? A catastrophic global outage. For hours, YouTube was just gone for most of the world. Yeah, that whole YouTube incident, it was a massive wake-up call for the entire industry. It was a terrifying demonstration of just how fragile the internet's core routing system was. It became crystal clear that the internet needed an upgrade. It was time to move from a system based on trust to a system based on proof. And the solution that engineers came up with is a framework called Route Origin Validation, or ROV. The goal here is pretty simple. Give network operators a way to actually verify that an autonomous system is the legitimate owner of the IP addresses it's advertising. It's an upgrade that basically bolts a security layer right on top of BGP's old, trust-based foundation. So how does this actually work? Well, it uses a system of digital certificates. A network owner, like Google, can create something called a Route Origin Authorization, or ROA. You can think of it like a digital title deed for their block of IP addresses, one that's cryptographically signed and impossible to fake. So now, when they make a BGP announcement, other networks can check that digital deed to verify their claim before they start sending traffic. It completely changes the game from just trust me to here, let me prove it to you. So when you peel back all the layers of the internet, you find BGP. It's this invisible, absolutely essential backbone that quietly works in the background, making billions of decisions every second, just to hold our digital world together. From its simple, trust-based origins to its more secure, verifiable future, it's what makes everything we do online possible. And that kind of leaves us with one last big question. The story of BGP is really a story of evolution, of a system that started out open and trusting and had to learn how to be secure. As we rely on the internet for more and more of our lives, what other foundational pieces will need to evolve to strike that critical balance between keeping things open and keeping things safe?